Okay, now that we've set the stage, let's dive into the core services that power a retrieval augmented generation, or RAG architecture. We'll start with data ingestion and indexing. So, the data ingestion service is responsible for getting raw data from all sorts of places. Think documents, databases, logs. It cleans and parses this data, then chops it up into smaller, manageable pieces. Finally, it creates embeddings, which are basically numerical representations of these pieces, ready for storage and quick lookups. You can think of this service like a really organized librarian. They not only get new books, but they also meticulously create an index for each one, so you can find any specific piece of information super fast later on. All these indexed embeddings? They get stored in what's called a vector database, which is specifically designed for really fast similarity searches. This diagram shows you the flow. Raw data from different sources goes into the data ingestion service. It gets cleaned, parsed, and chunked. Then, embeddings are generated and finally stored in the vector database. Alright, so we've ingested and indexed our data. The next logical step is to figure out how we retrieve relevant information when a user asks a question. This brings us to querying and retrieval. The retrieval service first takes the user's question in plain language. It then converts this question into an embedding, much like how we created embeddings for the data earlier. This query embedding is then used to search the vector database for data chunks that are semantically similar to what the user is asking. This is kind of like going to the library's reference desk. You give them your query, maybe as keywords, and they use that to find the most relevant books or passages for you. The main idea here is semantic similarity, finding things that mean the same thing, which is how we get the most relevant data chunks back. As you can see in the diagram, the user's query goes to the retrieval service. It's turned into an embedding, and that embedding queries the vector database to pull out the relevant data chunks. Okay, we've retrieved the relevant data chunks. Now, we need to actually generate a coherent answer. This is where LLM-powered generation comes into play. The generation service gets both the original user query and the context from the data we just retrieved. It then uses a large language model, or LLM, to put all this information together. The LLM's job is to create a response that's not only clear but also accurate, based on the context provided. In our analogy, the LLM is like an expert scholar. It takes the research materials we've gathered and then explains things clearly, grounding its answer in those sources. This diagram shows that the generation service takes the user query and the retrieved context, uses an LLM to synthesize them, and then outputs a grounded response. Finally, to make all these services work together smoothly, we need orchestration and integration. The orchestration service is super important for managing the whole RAG pipeline. It handles directing the queries, making sure the different components talk to each other in the right order, and can even manage the data ingestion workflows. Basically, it conducts the whole process. Here's something critical: understanding how these services depend on each other. If your data ingestion isn't great, retrieval might be inaccurate. Then, the LLM gets less accurate context, and the final answer suffers. Good orchestration ensures each step passes information correctly to the next, keeping the RAG process solid. The orchestration service really is like the central nervous system for the entire RAG pipeline, coordinating all the different parts. This final diagram shows how the orchestration service connects everything: data ingestion, retrieval, and generation. It also highlights this cascading effect. Data quality affects retrieval accuracy, which then impacts the final response quality. So, the key takeaway is that orchestration ties everything together for a robust RAG system. Now that you understand these core services, you're ready to start building your own RAG applications.